Good afternoon from my side as well. My name is Raphael. I'm a software developer from Heidelberg in Germany, and I've been the co-chair of DjangoCon Europe this year. And as this conference is coming to a close shortly, I will want to take the opportunity to thank the organizers for putting up this conference, because once you've done something like this, you get to really appreciate not having to do it and just sitting here and enjoy the wonderful conference that they created for us. Thank you so much for bringing me here to see this. Now, let's get to the topic I want to be talking about, which is data internationalization in Django. And before we do that, let's recap shortly what internationalization in Django without the data could mean. And we've had a talk, I think yesterday or the day before on the subject before. Django has a set of features that allows you to translate your application into other languages. This means that you can use certain functions to mark strings in your code or in your templates to say, okay, this is a string that is different when my application is not run in English or not used in English, but in another language. And then you can use the getText toolkit, which is like the standard translation toolkit in the whole Unix world, to extract all of those strings, create a file with all the translations, send it out to translators, collect the translations again, compile it, and use it. And that's great, but sometimes it's not enough. One of the open source projects I'm maintaining is Pretix, which is an open source ticket shop for events just like this one. And it allows you to create a shop that speaks to a multilingual audience. So if you have attendees coming from different countries or speaking different languages, you might want to present your shop in multiple languages at the same time. And that means it's not sufficient if only the application is translated. You need to translate data as well. And by data, I mean things that are entered by the administrator of the shop, for example, the names of the products or the description on how to get to the event and so on. That's all something that needs to be entered in multiple languages, and then in the output must be shown in the language of the respective user. So we need forms or some kind of input method that allow us to store data in multiple languages. So it's not really suitable to use getText for that, because we would need to, like every time someone changed something, we would need to generate such a file, send it to translators and so on. That just doesn't work. And so we cannot really use the tools provided by Django. Surely there is a third-party library that we just need to install and that will solve this problem for us. I've got good news and bad news for you. The good news is there is such a library. The bad news is I counted 23 of them until I stopped. So who in this room has ever used one of these libraries? Okay, that's not that much. Is there someone here who has written one of these libraries? Okay, that was more people at DjangoCon Europe last year. So disclaimer, I'm the author of Django I-18 Enfield. I put those 7 at the top who appear to be actively maintained. By that I mean they at least have a development branch that is compatible to Django 2.1, and they had commits like in the last 6 to 12 months. So I will be focusing on giving you a short, brief overview over those top 7 libraries, because the problem is there is not a single best library for this use case, because they're fundamentally different in their approach and fundamentally differently appropriate for the different use cases. If I get something wrong about one of these libraries, please feel free to correct me later on Slack. I haven't used most of them actually in an actual product, but I've played around with all of them. So to compare these, we want to look at different categories. We want to look at how the data is stored in the database. We want to know how their Python API looks and how easy it is to work with them. What other features they might provide, for example, integration with Django admin, integration with forms, and so on. And we are interested in if they have a significant performance impact and how large that is. So to have an example to work with, let's use a model where we can store a list of movies. And for every movie, we want to store the title of the movie and the year the movie was released. Obviously, the year is something that is not really local dependent, although it might be, but the title is certainly something that is different everywhere in the world, even though it's the same movie. So let's look at how different libraries try to represent that in a database. And the first approach that we see, for example, in django-hvad and django-parler is to have a separate table that contains the translated strings. So in our main table, movies, we have just the untranslated attributes with the ID of the movie and the year. And then we have a second table where every row references an object in the main table and then says, okay, for English, this is the name of the movie, and for Italian, this is the name of the movie. So this is, in terms of relational databases, this is a very clean approach. It kind of fits the normalize until it hurts that we learned yesterday. And if we are interested to like build our shop front end and we want to have or our movie list and we want to have a list of movies and we want to have the Italian title for every movie, then this is also very efficient because modern databases are very good at performing joins. However, for example, in the backend, where we want to have a list of the movies where we want to show every language per movie, this gets really expensive because we need to do either a lot of queries or we need to work with the query data a lot. A separate approach seen in Django model translation or Django translated fields is to just have separate columns per language. This way, you don't need any joins, and it's very cheap to get all languages at the same time. However, every time you add a new language, you need to do a database migration, which can be very annoying. And the third style that we see, used in Django I18N field, django-nece, and django-modeltrans, is to use a JSON-like field. This is less clean in terms of database normalization, but we don't need to do any joins. We don't need to do any changes to our schema when we add languages, and it's all contained in one field as we had it before. If we're on Postgres and if we use Postgres native JSON data type, we can still retain the functionality of filtering by or searching the name in a specific language or sorting by a name. If we're not on Postgres, we kind of lose the functionality to index or query that data. That might be a problem or might be totally fine for your use case. django-modeltrans is a bit different than the other two. It uses not one JSON column per translated column, but only one JSON column for the whole table, no matter how many fields you translate. But apart from that, those are pretty similar. Nece and modeltrans only work in Postgres. I18N field drops the indexing and filtering possibilities in there, but works on all databases. I'll be working at this sprints on something that uses the Postgres data type when you are in Postgres and gracefully falls back to a text field on all other databases. Next, we want to look at how you define your models. And there are, again, a couple of different styles. For example, in django-hvad, django-parler, and django-nece, you have a custom base class that you inherit your models from, and they will change your query manager and change a lot of things and how your model works to, like, as automatically as possible, build those joins for you or translate your queries for you. Sometimes you need to wrap your fields in some wrapper object to tell the library which ones you translate. Sometimes you have an additional meta option, but in the end, it's the same thing. The other style is that you have a custom field type and do not change the way the model in itself works at all. For example, in Django I18N field or Django translated fields, you just have a custom type that is a translated character field or a translated text field. Whereas in Django model trans, you like have per model, you have one field that is called I18N or whatever you want to call it, and that stores the translation for all other fields. The third style is to decouple it from the model definition process completely and have like a separate registry where you register those options. This is like the most, I would call it the most unclean style of doing it, because it's kind of not obvious where your code lives. On the other hand, this allows you to enable translations for models that are not in the code that you control, which might be something you need. Okay, here with such registration patterns. And the third thing I want to look at in detail is how to interact with your model objects. In some of the libraries, you can only interact with one language at a time. This is mostly because of this joins that they're performing. If you pull the object from the database, it will pull the information for one language. Like, you need to specify that within your query, and then the title attribute of the object will be populated with the Italian title. And then if you want to access the English title, you need to change the language, and it will perform a new query, or depending on the implementation, or in case of Nece, it will not, but it will change like the state, and title will now contain an the English title. The other option is to be able to access all properties at once. This comes naturally to the libraries where you have separate columns per language, because you have your main attribute title that usually evaluates lazily to the value of the currently active locale, and you can directly access every other language by just using title underscore and the language code, because that's just either because that's just the field that the library creates, or because it virtually creates it for you. In Django I18N field, it's a bit different. The title attribute will always contain a special data type, a lazy internationalized string, which is in some ways like what you get in return from you get text underscore lazy. It will, whenever you cast it to a string, it will coerce to the currently active locale, but it is a special data object that contains the information on all language. So you can pass that around as one object. So to recap and to add the other features, we have a couple of different database layouts that are in use. We have the version where we have everything in its own table, like we have multiple tables to store our model. We have the version where we have a very wide table with multiple columns for every language that we have, and we have the like embedded version within one column. We have database support for most of the libraries for all databases that Django supports, but in the case of django-nece and django-modeltrans, they only run on PostgreSQL. We have different levels of support for filtering the objects. For example, in those that use normalized database layout, it's really easy, although it might be computationally expensive. Whereas in those that use the PostgreSQL JSON field, it should be easy. They don't provide any utilities for you to make it even easier, like querying in the currently default language. You need to do that on your own, but it's conceptually possible, whereas in I18 field, it's currently not really possible. Like, searching somehow works, but ordering or indexing is not possible. We have the separate styles of defining the model, either by defining a base class, or by registration, or by a custom field type. And we have the separate styles of object operation, where we can either access one language at a time, or all of the language at once. I didn't talk in detail about form support. Some of them provide, for most of them, form support comes naturally by just like when they generate your model fields that have a separate column per language, then it will just, when you use a model form, it will just automatically generate that number of fields. So in some of them, you will get, in a model form, you will get a field that just allows you to edit the currently active language, which I don't think is useful in very many use cases. In some, you will like get different form fields for each, one form field per language. Nece doesn't have form support at all. It just gives you a text widget where you can edit the JSON blob. And in I18N field, you will get a special form field type with a special widget that it works like the compound datetime widget. It just has compound input fields within one widget to ask for the different languages. Some of them have very elaborate support for the Django admin and do that very nicely. Others just present you with the JSON blob or just different fields below. I did a small benchmark to have a look at their performance. The benchmark is, of course, not representative for a real-life application. It just stores a lot of objects into the database, pulls them out again, and tries to access the attributes in various languages. That obviously is rather slow on those that need to do joins and need to refetch, although at least django-parler can make use of caching to reduce this, while the others, quite unsurprisingly, the PostgreSQL JSON field back implementations are very, very fast, and the others are also reasonably fast. I've created a demo app that uses all of the 7 libraries and also contains the benchmark code in case you're interested in that. And with that, I'm a bit faster than I expected at the end of my talk, and I would be happy if you have any questions on that subject.
And that was a great talk, thank you.
Thanks.
Just one question. Where did you get the inspiration to do the emoji feature comparison?
I don't remember. I've seen a lot of emojis at the Django conferences I've attended. So it's maybe Katie's fault, but...
Hi, great, thanks for the presentation. Right to left support, how easy is that to implement, and how do the libraries succeed?
Mean in context of storing the data? I haven't tried. I don't see any problems ahead there, because in the end, those libraries are just about how to store these Unicode strings that users input and that we output at a later stage. So I think on this, on the model level, it's not that important. It might get more interesting if you have if you're rendering a form and you need to render some of the widgets with left to right CSS and others with right to left CSS. That might get interesting. But on the database level, I don't think it should be a problem.
Let's give a big round to Raphael.